I could start with, and now to something completely different, at least to something completely smaller. I really like what you said about millipetabyte. We have a 900 millipetabyte Ceph cluster running, and we are very happy with this. And yeah, I think Ceph is a really great system for very different kind of workloads. And I want to talk about one workload we use Ceph for, which is not actually a workload because it's not using a lot of performance, but which is really helpful for our users at our university. So I'm from Bremen University, which is a mid-sized university in northern Germany, and which is considered one of the more poorer universities in Germany. But Ceph is a great open source system for us as well. Who of you knows Seafile as a sync and share system? At least some of you. Who of you is using it in production? Even less. Seafile is just another sync and share system like OwnCloud, Nextcloud, or so many other systems. You have libraries like here. You can share things just from the web interface, or you can use a synchronization client on your laptop or on all of your computers and just sync things between your machines or your colleague machines and your machines. And this goes pretty well. What makes Seafile so special, especially in comparison to OwnCloud, Nextcloud, it has a very good performance, and it does not need a lot of hardware. So from our calculations, we think we would need at least 5 to 10 times more hardware for the same installation. We run all of our installation on a very lightweight hardware. This comes for some cost. One of the costs is that you don't have so many features in Seafile. You don't have a groupware, you don't have a calendar. You have some Office integration, LibreOffice, Microsoft Office integration, but that's better in OwnCloud, Nextcloud. And there is not only an open source solution, there's also a pro version, which is not free. And yeah, I'll talk on this later why you will need this for large installations. So, what do we do with Seafile? We have roughly 9,000 Seafile users, 3,000 of them active in the last few months. We have 35 terabytes of data, so not so much. But this data is spread over 150 million objects, or files if you use file system storage. So the Seafile is using lots of very small objects, and that makes it quite hard to manage the storage for Seafile to use. We have only one virtual machine where this is all running on, with only 8 virtual CPUs and only 32 gigabytes of RAM. And actually, the machine is mostly idle. Though our users are quite active using this stuff, we don't need the resources provided. At the moment, most of our stuff is on a ZFS file system based on an RBD volume in our virtualization solution. But we are at the moment migrating all this to S3 storage. And this is actually what I want to talk about here in this talk, how to use S3 storage from Ceph via a Rados gateway for Seafile. Ceph comes with several storage backends. At least the Pro Edition comes with several storage backends you can use. The default storage is file system storage, so it's just a folder on your hard drive. But you can also use S3 storage, OpenStack, or you can use Ceph via Liberados directly. So you can assign a Ceph pool or multiple Ceph pools to your Seafile, and Seafile will write directly into these pools, which is quite cool. But the problem is this is not supported in parallel with other storage backends. So for S3, you have the possibility to use it in parallel with file system storage, which makes up for a very nice migration scenario. But with Ceph storage, you don't have this opportunity, at least at now. The Seafile guys think about using, putting the multiple backend stuff into the Ceph integration code, but it's not sure if this will come in the near future. So to use S3 as a storage backend, you will need 3 buckets in your Rados gateway. And this is how Seafile looks at storage in general. You have always a distinction between 3 very different type of objects. You have commits, you have FS objects, and you have blocks. And for all of these 3, you need 3 buckets. When you use file system storage, you have 3 main folders under your storage folder, which are just titled commits, FS, and blocks as well. Then you for sure you need an S3 user in your Rados gateway, and you should really consider to set up placement target rules for putting the Seafile data in specialized pools, at least for the data pool and also for the index pool if possible, so that you can manage your pools much better, distinct from your other S3 pools. But this is very well documented in the Ceph documentation project, so you can get it from there. In the Seafile configuration, it's pretty easy. There are 2 configuration files. The upper one is for the Seafile backend server. There's just 3 lines to add like this. And for the Seafile web front-end server, just 2 lines where you just tell Seafile you will need that you want to use multiple storage targets. And for the storage targets itself, you will have to put up a JSON file, which is a little bit more complicated. Looks like this. But this is well documented in the Seafile manual. And at the end of the presentation, you will find a link for some examples from our installation where you can download all the stuff I'm talking about here. So the main thing you see here is that you select a storage ID, which goes into the database later. 1 for file system, 1 for the S3. And we'll have to tell Seafile what is the default storage to use. And if you have an existing installation which uses file system storage, you should really make sure that you start your Seafile with the file system storage as the default storage. Otherwise, you will not have any access to any data. The main reason for this is that Seafile, as long as you don't use multiple storage backends, does not store the storage target in its database. So as long as you don't have multiple storage backends, Seafile does not even know about your storage backend and just uses the default backend. And if you set up multiple storage backends initially, you'll have to tell Seafile where your default storage is and where you want to put your data in. And this must be done manually in the database. Here's some code for just setting storage ID for every repository in use. The repositories, the libraries in use are in the repo table here. And what is a little bit under-documented in the Seafile manual is that you'll have to do this not only for the repo table, but for the garbage repos, the repo trash table, and just to be sure, for the virtual repo tables as well. So you have to do all these insert queries. And after that, you can change the default storage in the JSON file, and Seafile will know where all the old data lives, which you want to migrate later on. Another more or less annoying thing is that in the old stable version 6, the S3 backend just don't work. But there's a very small backfix needed from version 7 to version 6, which you can find on our website on the link provided later to get the S3 storage backend to work. If you have your S3 storage running in parallel to your file system storage, you might want to migrate from the old storage to the new storage. This is at least what we want to do and what is at the moment running at our Seafile installation. We think we will end this task by the end of the year. But We can do this in background without any interruption to the production system. When you look into the Seafile stuff, you will see migration scripts from file system storage to any other storage which is supported by Seafile. But these migration scripts provided from the Seafile guys are only working with offline migration. And we calculated roughly 1 to 2 months offline migration time, which would be a no-go. So putting our Seafile down for 2 months would really be annoying for our users. So we decided to reverse engineer the data model, which is derived from Git. It's pretty simple, actually, and do an online migration script on our own, which is now running for maybe 3 months or so. And at the end, we hope that we have our 35 terabyte in the S3 storage and not in the file system storage anymore. So when you look onto